All right, I got a couple more examples I want to go through here with you. So let's do this one. We're going to solve this triangle ABC given this piece of information. Angle A is 42.3 degrees, side B is 12.9, and side C is 15.4 meters. So that's the whole point here, right? I'm solving this triangle. So write out what we know. We know we need an angle A, angle B, and angle C. Side A, B, and C. So my angle is 42.3 for A. Side B is 12.9 and side C is 15.4. I also like writing this out because now it is super obvious I have nothing that matches up. So you have to use law of cosines because law of sines is not going to do it. All right? So the first thing we're going to find is this other side. So let's use some cosine action and pull this off. I know that I'm going to have a squared is equal to 12.9 squared, 15.4 squared minus 2 times those. And the cosine of that angle. Chug that out. A squared is going to end up being 109.7. Now, always pause the video and actually work this stuff out, right? I've worked it out in advance so I can see what this answer is. I'm not chugging this in my calculator that fast. I just don't want you also to have to sit there and wait while I put something in my calculator on a video. So pause the video, plug it in your calculator, make sure that this is all working, and you come up with 10 that's a 10. 10.5 is what I get for A. Now, here's the deal, guys. I now have a matchup. So make your life easy, right? It is so much easier to use law of sines than it is law of cosines. And the rule of thumb here, whenever I'm going through this, is as soon as you have that matchup, then you just start working things out. So I'm now looking at this. And I'm going to figure out B. We're just going to go down in order. Yeah, 3 significant digits. Okay, we're good. So now I'm going to go just down in order. I'm going to find angle. So sine of B over 12.9 is equal to the sine of 42.3 over 10.5. So the sine of B is now equal to 12.9 sine of 42.3 divided by that 10.5. So my sine of B here is equal to 0.81, which we should have expected because we know for a fact these are actual triangles. So we're good there. And then I do inverse sine for this one of 0.81 to get my angle B. And B is 53.89. Oops. Which I know with everything else I'm looking at, it's one decimal with my significant figures. So 53.9 degrees. And as soon as you know 2 angle measures, it's super easy to come up with the third. Minus 42.3, minus 53.9. So if I do all that work, 83.8 will give me C. And you have found the rest of it. So use your law of cosines, but you also are going to integrate our law of sines to go with it, right? So once you use your law of cosines and you have that set up, then go back and you can use your law of sines in order to help yourself out. All right, let's do this one. Example 4 says, solve triangle ABC given only sides. A is 5, B is 6, and C is 9. So this is the first time that we start here with only sides. Now here's my tip for you. Typically, we start by finding the largest angle. How do I know which one is the largest angle? Yeah, pardon me, I'll try it again. I know I have the largest angle because it's the largest side. So C is what we're going to go for, and we're going to find that first. Okay. Let's do it. Now look at what's happening here. I want to find cosine. So I actually have c squared is equal to a squared plus b squared minus 2ab. Here, cosine c. So my goal is I have to work my way in to this cosine c. You can plug everything in and work it. You can also solve for c and then plug that in. I don't care. Whatever you want to do. Everybody has their own thing. If you want to solve for the variable first, you can, and then plug it in. That's how your book has you do it. You can do that, you cannot. It doesn't matter to me. The goal is to get that c by itself. So you're plugging in everything else. So I have 9 squared is equal to 5 squared plus 6 squared minus 2 times 5 times 6 and cosine c. All right? So you can work all of that together if you want to. So I've got 81 is equal to 25 plus 36 minus 60 cosine c. I can put that 25 and that 36 together. I should have done it in the last step. That would have made more sense. 61 minus 60 cosine c. Subtract 61 from both sides. Oops, cosine c, not 6. Divide both sides by that negative 60. And I end up with cosine c here is equal to this negative 1/3. Then I take that inverse. So C is actually going to end up with 109.5 degrees. I already know this is a triangle, so I don't have to worry about that being negative. It's no big deal. I'm going to end up with 109.5 degrees. Oop, I didn't write it out, did I? So I have angle A, angle B, angle C, and then all of my different sides. So I have 5, 6, 9. And my first one is 109.5. Once you come up with 1, then you just have to solve for the rest. I'm just going to go up the line up here. So the next one that I'm going to solve for is going to be, a lot of times you can go back, then start at A and work your way back down. You can go, I don't know that it really matters. So if I have sine of B, if I go and find the next one here, sine of B, because that's what I'm trying to find, over 6 is equal to the sine of 109.5 over 9. So the sine of B is equal to 6 sine of 109.5 divided by 9. So B, so you can take the inverse there, right? B is going to be 38.9 degrees. If I wanted to figure out A, I now have 2 of my other angle measurements. So I'm going to take 180 minus 109.5 minus 38.9, and that's going to give me A. So A is going to end up being 31.6 degrees. All right. If you have these three sides, then you're going to come up and find the other ones. And then you'll be good to go. All right. All right. So if you have three sides, that's how you work it off.